Hello and welcome to StatLab StatCrunch videos. Today we're going to be talking about chapter 6.1, which is confidence intervals and margin of error. Okay, so we are on section 6.1, problem number 4. Researchers studied that the mean egg length for a bird population, after taking a random sample of eggs, they obtained a 95% confidence interval of 45 and 60. So the confidence interval is from 45 to 60. So the lower limit is 45, upper limit is 60. What is the value of margin of error? So we know that, let me go ahead and click. Okay, so the lower limit is 45 and the upper limit is 60. The margin of error is your upper limit minus lower limit divided by 2. You gotta excuse my handwriting, my mouse is not cooperating with me today. So it is 60, which is your upper limit, minus 45, which is your lower limit, divided by 2, which is 7.5 millimeters. Oops, the M looks good. Okay, 7.5 millimeters. So that's what the answer is going to be. I'm going to stop this, and check my answer. Very good. All right. Moving on to problem number 10. Find the critical values. There are two ways of finding critical values. One is using your chart, but in class we did not use the chart. We used the StatCrunch calculator. So I'm going to go ahead and open that now. Let me see if it's opened up somewhere here. Yep, it is. Okay. So I go to Stats, Calculators, Normal Calculator. Okay. I'm going to go ahead and show that to you. It's a normal calculator. And my confidence intervals are always between. What is my area? 92. So I'm going to go ahead and put 92 and compute. So my confidence interval is negative 1.75 and positive 1.75. I'm simply going to go ahead and put the positive 1 let me see what it was. 1.75, yes. 75 and check. There you go. Moving on to the next problem, problem number 11. For this one, we simply have to find confidence interval for 95. Remember how we find confidence interval? Go back to the previous problem and you're going to use the formula error is equal to ZC standard deviation over square root of n. So you're going to plug in. Remember how to find your ZC for 95? Let me go ahead and show that to you one more time. You will go to your StatCrunch. In between, it is 95. So this is going to be 95 and compute. So my critical value is 1.96. Okay? So I'm going to go ahead and plug that in here. So it kind of goes off when I change it. So ZC standard deviation square root of n. My critical value is 1.95. Standard deviation is times 3.4 and square root of 81. Okay? So that's how you calculate the error. I'm not going to do the math right now just to save us more time, but this is how you're supposed to do it. You're going to plug into the formula and you're going to calculate your critical value ZC like I just showed and then plug it in there. Okie dokie. Now moving on to the next problem, problem number 12. For this problem, we will be using our StatCrunch, so pay attention. Stats, ZStats, one sample with summary. Okay? Stats, ZStats, one sample with summary. You're going to go ahead and plug in your mean. What is my mean here? The mean of the sample is 6.2. So 6.2. Standard deviation is 0.5. and the n value is 54. Okay, and you're going to go ahead and click confidence interval. You're going to go ahead and click confidence interval, and you click compute. So once you have that, you have your lower limit and your upper limit. So let me go ahead and put that there. Oops, excuse me for that mail. My lower limit was, let me minimize this one too. When I minimize this, I can see my lower limit. Okay. My lower limit is 6, 2 decimal places, did they say? Yeah, 6.07. My upper limit is 6.33. Oh, did I put 9 point confidence interval? Okay, I think I put confidence interval 95. This is 98. Confidence interval is 98. Okay, now it changes. 6.04 and 36. Okay, your confidence interval has to match. And you check your answer. That is fantastic. Okay, quickly refreshing. You'll put your sample mean, your standard deviation, sample size, and then you will make sure you have the same confidence interval. And you have to check this button. Okay? Okie dokie. Now moving on to the next problem. Problem number 14. Okay. In this problem, they ask us to estimate the margin of error. And I think we did that in the previous one. Margin of error is upper limit minus lower limit, which is 4.1, divided by 2. In this case, my margin of error is 0.5. Let me go ahead and put that 0.5. Check my answer. Very good. They ask me for sample mean. Remember what the margin of error is. Sample mean is all the way in between, and you have 5.1 here, your upper limit, 4.1 here, your lower limit, and this distance, let me change the color. And this distance is your margin of error, which is 0.5. Okay, this distance is 0.5. Oops, it's not straight, but you get the idea. Okay, so what they're asking me to do is they're asking me to, let me pick another color. Okay, so they're asking me to find the sample mean here. So they're asking me to find x bar, which is this particular value. All I can do is add simply 4.1 to 0.5 to get this one. Or you can subtract 0.5 from 5.1, either way. But I'm just simply going to go ahead and add 4.1 to the margin of error 0.5. That way it's going to keep it simple. Okay, I'm going to have to press this one. 4.1 plus 0.5 is 4.6. Your sample mean is 4.6. Okay? Alright, so the next question is question number 16. Alright, so in this question, it says a publisher wants to estimate the mean length of time all adults spend reading newspapers. To determine this estimate, the publisher takes a random sample of 15 people and obtains the results below. From the past studies, the publisher assumes the standard deviation of the population is 1.6 and that the population of time is normally distributed. Okay, so I have the data here. It's very important we understand the difference between the data and the summary. I think I discussed that in class. In this case, I have my data 10, 9, 10, 11, 7, 7, and so forth. What I would do is go ahead and open the data in StatCrunch. There you go. And I'm trying to find the confidence interval. So I go to Stats, Z-Stats, one sample. Remember, it's not the summary. They give us the raw data set. So this is my data. Variable 1. I will go ahead and plug in my standard deviation. My standard deviation is 1.6, which goes right here. So I'm going to go ahead and plug that in. 1.6. Scrolling down, confidence interval, it's 90%. So I'm going to go ahead and show that to you. It's 90%, which goes right here. 90% and compute. And if you see that, my lower limit is the lower limit here, and my upper limit is right here. Okay, and you would do the same thing for the lower limit and upper limit of 99% confident interval. So I'm going to go ahead and show that to you. Edit, I'm simply going to change the confidence interval to 99 and compute. There you go. I have 8.1 rounding off, 10.2 rounding off. Okay, and the next question they ask is which one's wider? Just look at the data set here. It's 8.5 to 9.8 and 8.1 to 10.2. So definitely the 99% confidence interval is much wider. And if you look at the area under the curve too, area for 99% is wider than area of, let me change the color here. Let's pick yellow. Area of 90%. So area of 90% is going to be only this part, but area of 99% is going to be way beyond. So that's wider. Hope this helps.